Hi friends, welcome back to the chapter D block element. In this given module, we are going to learn about the ionization enthalpy, that is the next property of the transition element. Now, if you will see, ionization enthalpy is the amount of energy required to remove the most loosely bound electron from an isolated gaseous atom in its ground state. Now we know that the unit that is used to calculate ionization enthalpy is electron volt or kilojoule per mole. Now let us see the different factors which are affecting. The very first factor we are talking about is what? Nuclear charge. As the nuclear charge increases, then ionization enthalpy increases. The second factor we are talking about is atomic radius. So atomic radius is what? Inversely proportional to ionization enthalpy. I mean to say, as the atomic radius increases, the ionization enthalpy will decrease. Last factor, which is shielding effect or screening effect, which plays a very important role in deciding the ionization enthalpy. In case of transition element, the inner electrons which are present into the D, and in case of some transition element it is consisting of F also. So D and F, since they provide poor shielding effect, the nuclear charge certain increases onto the valence shell and the ionization enthalpy increases. Now if you will see this graph, which is actually indicating first ionization enthalpy in kilojoule per mole onto the y-axis, onto the x-axis if you will see transition element. So let us compare the first transition series, that is 3D transition series. If you will check from titanium to copper, then you will find the ionization enthalpy increases first. It reaches to maximum value, and again this increase is not very regular. So this irregularity of the ionization enthalpy is actually supported by the fact that added electrons enters into penultimate shell, I mean to say n-1d subshell, and it shields the valence electron. Thus, the effect of increased nuclear charge is opposed by the screening effect of the penultimate shell, that is n-1d element. Now, if you will compare, the same happens into the 4D series, but here something very important which should be noticeable is the first ionization enthalpy of third transition series, that is 5D series, is very high. This, if you will see, because this series of element, that is third transition series element, is consisting of F electron along with the D electron into their pre-penultimate and the penultimate shell. So what happened, as the added electron enters into F subshell, due to which the shielding is extremely poor towards the valence electron from the nucleus. So as the shielding decreases, force of attraction increases and the ionization enthalpy increases. So I can say ionization enthalpy of third transition series is very high as compared to first and second transition series. Now different transition series ionization enthalpy can be explained by considering this table. If you will see, ionization enthalpy of first transition series increases from left to right. This is due to the decrease in atomic radius, but slightly increases for the last element because of the electronic repulsion and also because of the stable configuration. So in case of chromium, if you will see, it is ionization enthalpy is high. It is due to the availability of the D5 configuration. In case of copper also, ionization enthalpy, second ionization enthalpy is very high. It is due to the completely filled d orbital. And in case of Fe, if you will see, the third ionization enthalpy is less because they want to achieve half-filled d5 configuration. So after this, if you will compare, in general, as high value of ionization enthalpy is due to completely filled 3d10 configuration. For example, in case of zinc, they have completely filled d orbital. Now after this, it is ionization enthalpy is used in calculating thermodynamic stability of some metal compounds, some metal complexes. For example, if I am comparing nickel and the platinum, so remember, lower is the sum of ionization enthalpy, higher will be the stability of that metal ion. I mean to say, low is the value of ionization enthalpy, greater will be ease or tendency to form complex compound by that transition element. If I am comparing nickel and platinum in their di-positive oxidation state, so you will find the sum of two ionization enthalpy for Ni2 plus is less as compared to platinum 2 plus. So I can say that nickel 2 plus is more stable than platinum 2 plus, or I can also say that nickel 2 plus complex is more stable as compared to platinum 2 plus complex. But if I am comparing nickel 4 plus and platinum 4 plus, then you will find platinum 4 plus is having less sum of 4 ionization enthalpies. So again, now this time stability goes toward platinum 4 plus. I mean to say platinum 4 plus ion or platinum 4 plus complex is more stable as compared to Ni4 plus. So that's all in this model. Thank you very much.